Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Mayfield. In this video, we're going to be working on some Pythagorean Theorem notes, but we'll do some quick math to start us off. So without a calculator, list these perfect squares and square roots. So we're going to do 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and 7 squared is 49. Again, make sure you're saying squared raised to the second power, or raised to the power of 2. Any of those would work. And all that's saying is what would be the area when a side length has 2? It would have 4 total squares. If you had a side length of 3, what would be the area? It would be 9. So if you want to use graph paper to see that, what would that look like? Then it says for these square roots, it's asking, well, if this is the area, what would be a side length of one of these squares? So again, square root of 400 is 20, square root of 361 is 19, square root of 324 is 18, square root of 289 is 17, square root of 16 is, let's try that again, square root of 256 is 16, and yes, you guessed it, the square root of 169 is 13. So make sure you're seeing the not pattern that is there and moving on. So now, some brand new information that we're going to be talking about and making sure that we can understand is we're going to use the Pythagorean Theorem when we are talking about right triangles. So let me actually make sure that says triangles for you. Right triangles. And it's already in there, so that's okay. Again, the way to pronounce that is like this. You would say Pythagorean, Pythagorean, and Theorem. So again, Pythagorean Theorem is what we're talking about. Again, a right triangle is a triangle with one right angle. In that right triangle, the two sides make the right angle called the legs. The side opposite or across from the right angle is called the hypotenuse, and that's going to be the longest side of those three. Again, triangle, 3 sides, the longest is called the hypotenuse. Again, the Pythagorean theorem describes the relationship between the side lengths, or the lengths of the legs, and the hypotenuse. Again, the way we pronounce that is like this. We say the hypotenuse, and it is the largest of the 3 sides or values. So make sure you can hear how I am saying it. Say it out loud for yourself. I will make sure that you are doing that carefully as well. So let's try some main ideas here. So again, when you go to label this, make sure you can see these sides. So we're going to say always be able to identify, again, that right angle is what that box means, and opposite of that right angle, I'm going to draw an arrow pointing to the hypotenuse, which we usually say is C. That means the other 2 sides that are adjacent to each other are going to be leg A, which disappeared. Let me make sure they're the whole way out. So we're going to say this is going to be leg A, and this is going to be leg B. Again, these are interchangeable, so again, you could say this is leg A and this is leg B, as long as you're knowing that those 2 sides that are adjacent to the right angle are the legs, or the side that is opposite of the right angle is always the hypotenuse. So you have to say always that a hypotenuse is opposite of the right angle. So now what are we going to say? Well, again, that key definition for ourselves is going to be the Pythagorean theorem says, given a right triangle with legs A and B and a hypotenuse C, we have a squared plus b squared equals c squared. Again, if a lot of people are going to say a2 b2, I'm going to be really upset with you. Again, this is squared, or a to the second power. And what that's saying is this: when we know this is a right angle, and a right triangle, we can use this formula. So let's apply that Pythagorean theorem to see what we can come up with. So it says, is this a right triangle? And so we want to use what we've learned about those right triangles to determine if the three side lengths will create a right triangle. So we're given three values and we want to see, okay, is this actually a right triangle? And so the way we can do that is like this. We have to say, all right, given these three sides, which one is the hypotenuse? Again, that's the largest side. So what we can say is, all right, well, first off, we know the hypotenuse is 13. And so now we can write the formula. So we're going to have a squared plus b squared equals c squared. And so we're going to say, all right, now what do we do after that? We can substitute in our values for our variables. And so again, we plug them in like this. We have 5 squared plus 12 squared. And we're saying, is this equal to, that's why the question mark is there, we're saying, is this equal to 13 squared? Again, notice that the c is that hypotenuse, and we identified that first, so that's why we have it there. And lastly, we can just simplify. So again, working left to right, make sure you can simplify carefully. So we're going to say 5 squared is 25, and 12 squared is 144. So again, it's going to say this, we're going to say 25 plus 144, is that equal to 169, because we're trying to confirm that this is a true statement. If you simplify it carefully, you will know, yes, since this is equal to each other, we know this is accurate. So we'd say, yes, this does form a right triangle. For the second one, same setup. Make sure you can identify the largest side. Let me move this over a little bit. That way we can see what we have. If it will let me. Maybe. There we go. Alright, so again, identifying the largest side for yourself. And so we're going to say, alright, out of these three numbers, 17 is the largest. So we know that has to be the hypotenuse. So again, we're going to say, alright, we want to be able to write that formula out for ourselves. So we're going to have a squared plus b squared equals c squared. Let's substitute in our values for our variables, and so we're going to say, all right, is 8 squared plus 15 squared, is that equal to 17 squared? Again, notice the question mark because we're trying to see if this is correct. Again, then we can just simplify. So we're going to take 8 squared, which is 64, and then we're going to have 15 squared, which is 225, and then we have 17 squared, which is 289. And we're saying, is this going to be equal to each other? Again, make sure you are calculating carefully for yourselves. And then you could say, well, since the left side is equal to the right side, we know this is a true statement, and therefore it is a right triangle. So you can make sure that you're seeing these ideas with this. And so continuing with that, again, you can see for the next ones, it looks like this. It says for 4, 8, and 10, we want to see, all right, let's identify that hypotenuse, which is going to be the largest of those three, so it's going to be 10. It doesn't always have to come first or last. Make sure that you are careful with that. We want to write that formula out. So we're going to say a squared plus b squared equals c squared, and we can substitute in our values for our variables. So we're going to have 4 squared plus 8 squared, is that equal to 10 squared? And so again, we can now simplify. And so we want to say, all right, if we do 4 squared, it's 16, 8 squared is 64, and 10 squared is 100. And we're saying, are these two sides equal to each other? Well, when you add up 16 and 64, you only get 80, which is not equal to 100. And so we would say, no, it is not a right triangle. So again, we're seeing, do these three sides form a right triangle? And for this one, it does not. And for the last one, same idea. Identify that hypotenuse for ourselves. And so we can say, all right, of those three, the 29 is the largest. We want to make sure we can write out our formula. which is going to be a squared plus b squared equals c squared. Again, this is the most important part, so at the very least have that down first. Again, we can now substitute your values in for your variables. So again, our legs are going to be 20 and 21, and then our hypotenuse is going to be 29. And we're saying if those side lengths are squared, do they add up to equal 29 squared? Again, we can now simplify. So we do 20 squared, which is 400, and then we have 21 squared, which is 441. And we're saying those two added together, is that equal to 841? Which, since it is equal to each other, we know this is a right triangle. So we'd say, yes, it is a right triangle. And for the last two, it looks like this. So now what we want to do is we want to use those ideas that we have to see, all right, does this missing side, how do we find that missing side? So again, let's see what we have. So we have a right triangle here, and we know that we can say, all right, we want to make sure we are identifying that hypotenuse first. Again, that's going to be that side that is opposite. So if you have a picture, make sure you can draw opposite of that. So our hypotenuse for this is going to be x. So that's what we're actually going to be looking for. So now we can write that formula out. So we can say it's going to be a squared plus b squared equals c squared. And then we can substitute those values in our four variables. So our two legs are 9 and 12, and we're going to let x be our hypotenuse. So we're going to solve for x. So again, we're going to solve for x. So how do we do that? Well, again, we can use those ideas like before. We can simplify one side, and then we can evaluate it like a normal equation. So I'm going to have 9 squared, which is 81. I'm going to have 12 squared, which is 144. Again, since we don't know what x is, we let x squared stay the same. We can add these two together to be 225. And now here is the key part. We want to make sure we can take the square root of both sides. So I'm going to take the square root of the left side and the right side. And what that does is that helps us identify what integer value, or what whole number, more specifically, we would have. Because we're trying to find this side length of x. Again, we're trying to find this side length in here. And so again, if we take the square root of 225, we end up with 15. And the square root of x squared is just x. Again, this is an inverse operation, which is why I do it in the first place. So again, we know that this side length is going to be 15. So again, make sure you're seeing that for yourself. You can calculate it using that Desmos calculator. And to prove your answer, again, make sure you can take the square root of both sides. And for the last one, so instead of finding a side length, instead of finding a hypotenuse, we're now going to find a side length. So let's see what this looks like. So if we have 24, 25, and x, we want to make sure we can identify the hypotenuse first, which that's going to be the side opposite of the right angle. So 25 is going to be our hypotenuse, which means we're looking for a leg. So again, we can write our formula out as a squared plus b squared equals c squared. Again, make sure you can get that down for yourself. We want to substitute those values in for our variables. And so we're going to say, all right, well, I know one of the legs is going to be x. So I can just let either a or b, it doesn't matter because those are both legs, and we can let that be x. And so we're going to say, all right, we have x squared plus 24 squared, and we're saying that's equal to 25 squared. Again, to solve, we are going to solve for x. We want to make sure we can simplify what we can. So we're going to do, since we don't know what x is, we let that x squared be itself. However, 24 squared is 576, and 25 squared is 625. So now we can set up a two-step equation. And so what I'm going to do is this. You can draw a railroad tracks, training wheels, whatever you want to call them. And I'm going to get that x by itself. And how am I going to do that? Well, I got to do my inverse operations. So I'm going to get all the constants on one side. So I'm going to subtract this 576. Whatever I do on one side, I have to do to the other, so I subtract it on both sides, and I end up with this. I end up with x squared equals 49. Again, the 576 cancels out, and we're just left with 49. So now we have x squared equals 49. What do we do? Well, the only inverse operation we can do is take the square root of both sides. So we take the square root of both sides, which gives us x equals 7. So we'd say, again, x is going to be 7, which is this side length here. So again, make sure you are seeing those steps carefully for yourself. Again, be able to ask questions very carefully.